In this video, we'll be going over the tasks for Practice 7, which involve running a power and sample size analysis in GPower. If you haven't done so already, please download and install this application before continuing with the video. The first thing we want to do is open GPower. If you have a Windows computer, you can search for the application in your Start menu. And if you're in a Mac computer, you can either click F4 on your keyboard or click the Launchpad icon in your dock if it is present there. You should see the GPower application and should be able to open it from there. When the application opens, it'll look something a little bit like this. For today's example, we're going to keep things fairly simple and just test power for two samples or two independent samples. So we haven't talked about t-tests yet, but when we compare two samples together, or compared two samples to each other, we would use a t-test. Under the statistical test section, we're going to choose means, differences between two independent means for two groups. And then the first power analysis we are going to run is an a priori power analysis. So we would run an a priori power analysis when we've collected some pilot data and we want to know what the required sample size would be given a certain alpha level, a power level, as well as an effect size. We haven't talked much about effect size yet because we haven't been comparing means in a way that effect size would be important to us, but the effect size that we would input in this test is Cohen's d effect size. And I quickly want to show you what effect size means for a brief introduction. I've linked this source in the Module 3 checklist under the Review, Practice, and Study section. And basically what effect size is it tells us what the actual difference between two samples or multiple samples would be. So you can see that the black curve here is our control group, and the blue curve here is our treatment or exposure group. We've previously talked about overlap between distributions, and we've talked about confidence intervals. So in previous discussion, we said that the more the confidence intervals overlap for our control and treatment group, the less different or the less significantly different they're likely to be. The less overlap, the more significantly different they're likely to be. Well, when we do certain statistical tests and we get p-values that tell us if we have a statistical difference or a statistical effect or a significant relationship, they don't exactly tell us how big that effect is. So Cohen's d effect size actually tells us how large of a difference we have between two means if we're comparing two samples. Here we have Cohen's d of 0.8, which is considered a fairly large effect size. And we can see that the difference between our means, if this is some given outcome, the difference that we've detected is fairly large. If we had a test that was comparing two means and it showed a p-value less than our alpha level, that would indicate we have a significant difference. The effect size just tells us how big of a difference that significant difference actually is. So the larger the effect size that we're looking for, the smaller the sample that we need. If, however, we wanted a more moderate effect size, such as 0.5, you can see that the overlap between these two samples gets a little bit bigger, and thus the difference between our means gets a little bit smaller. Again, if we wanted to do an even smaller effect size, such as 0.2, we can see the overlap increases even more. So the smaller and smaller the effect sizes, or the smaller and smaller the differences that you want to be able to find between your groups, the larger the sample size you're going to need. When we look in G-Power then, and we're doing an a priori power analysis, we can identify how many tails are in our test. We can identify the effect size. So for now, we're going to do an effect size of 0.5, which would be considered moderate. And then our alpha error of probability will stay at 0.05, meaning that we have a 95% level of confidence. And we'll set our power to 0.8. From here, we can click Calculate. And G-Power will tell us that we need at least 64 people in our sample size for each group that we're comparing to each other in order to achieve a power of 80%. Now we can change these values, say to 0.2, which was our small effect size, and we can see that the smaller the effect we want to be able to detect in our sample, the larger our sample actually needs to be. In contrast, if we did a larger effect size, such as 0.8, we can see that our sample size needed to achieve a power of 80% decreases to 26 for each group. Now, this again is a scenario if you were doing pilot testing and you kind of wanted to know how big your sample should be based on the effect size you're trying to find. Additionally, we can do a power analysis that is post hoc referring to run after data collection and analysis. And we can see if we've achieved a certain power given our alpha, our sample size, and a given effect size. So let's keep our two tails. Let's go back to a moderate effect size of 0.5. Our alpha error probability will stay the same. And this is where we're going to use our practice 4 data to identify the sample sizes of groups 1 and 2. The practice 4 data, if you recall, was looking at lung capacities for various health statuses. We can just split this up into males and females. So again, a quick way to do this is to apply a filter. And then sort, just do this one, ascending for males and females. So then from here, I can just scroll through all of the data that has a label of 1. And then I can observe that the count of females, or the number of cases that I have, is 51. So I can go back to G-Power and say that the sample size of group 1 is 51. From there I can see how many males that I have in my sample size, and we can see the count is 47. So for my sample size I will put 47, and then we can click Calculate. We can then see that our power is 68%. And remember that power is 1 minus beta. So in this distribution, this blue curve here, we can see that beta is over here, which means that power is on the other side of this critical t-value line in the middle. If we did 100% minus 68.7%, we can find the probability that we made a type 2 error, which involves accepting the null hypothesis when the null is actually false.